दोनों वाले, एक टू लेकर आओ। तो बात नहीं, आराम से एक मिनट बाद लेने दो, बस all right, done. So please tell me what is the length that you measured between P and Q on your screen. Tell me the length, please, and also tell me
It's
the number of
4.9.
waves.
It's 4.9, which turns out to be 19.6 in the tank
Four.
because 1
Okay.
centimeter represents 4 centimeter.
All right. So 4.9 is this length P to Q, right?
Yeah, but like
Okay.
if we talk about the diagram, it's 19.6 because the
It
question says that 1 centimeter represents
fine, fine,
four
fine.
centimeter in the tank.
Just okay. I'm just asking that whatever you have measured using your scale, then this length from P to Q, was it 4.9?
Yeah, it was.
This was 4.9, right? Now tell me the number of waves that are forming here between P and Q. Tell me the number of
Five.
waves. Five. Okay. How? This is starting point. So zero, one wave, two wave, three wave, four, and five. Right. 4.9 is the length for five wave. So one wave would be what? Lambda. And that would be 4.9 divided by 5. 4.9 divided by 5. So that means one wave is how much? Please calculate this.
0.98.
0.98 centimeter, right? This is one wave. 0.98 centimeter. This is one wave.
Yeah, I got one like full one because I measured it. It was like five, and then like
Okay, fine. It can vary. It can vary. The examiner will definitely give you a margin for this. That's not a problem. Then determine the term frequency. How do you define the term frequency?
I have a really short definition for that. It's like a number of complete wave in 1 second.
Number of complete waves in 1 second. All right. What about you, Vada?
Yeah, that was me.
Sorry, Hina.
In like what I like call it is number of vibrations per second, which is
All right.
frequency.
All right. Perfectly fine. Not a problem. So number of vibrations. You can say number of waves. You can say number of wavelengths. Hmm? Or you can say oscillations, per unit time. Per unit time. So frequency is the number of waves. Number of waves. Frequency is the number of waves formed per unit time. Formed per unit time. Right? All right. Determine the frequency of the wave. Frequency is what? Frequency is, if I talk about speed, speed was v is equals to f lambda, right? F lambda. Now they're asking for frequency. So how do I find frequency? Have they
V
given me
divided by
anything?
lambda. V divided by lambda.
They say a crest takes 2 seconds to travel from P to Q. So if a crest takes 2 seconds from P to Q, That means how many waves are forming there? 5 waves. How many waves are forming there?
5.
5 waves. So frequency is number of waves in a unit time. What are the number of waves? Number of waves formed are 5. What is the time taken?
2
2
seconds.
seconds, right? So what would be the answer? 2.5 hertz, right? 2.5
Yeah.
hertz. 2.5 hertz. All right. Next, the wave generator is a bar of wood. Describe how it is used to produce the wave shown. So how does the wave generator produce a wave? What can we write for this? When the wave generator moves the bar up and down regularly at constant frequency, it will result in what? It will result in energy from the generator to be transferred to the water wave or water particles, forming a wave. Is it?
Yeah.
All right. So what will happen? How it is used? The wave generator, right? Wave generator is a bar of wood. The bar of wood is moved up and down. The bar of wood moves up and down. Moves up and down. And energy is transferred. Energy is transferred to the water particles. Energy is transferred to the water particles. Water particles forming a wave. Forming a wave. This is a complete answer formed, right? What would be the examiner looking for is that if you have mentioned the up and down movement, if you have mentioned the up and down movement, right? And what else he will be looking for in your answer is it that if you have mentioned that the energy is transferred or wave is formed. Okay, so moves up and down. Yeah, and you need to mention that regularly. It's it's done regularly. You need to mention this, okay? You need to mention moves up and down regularly. You need to mention this regularly, right? And energy is transferred to the water particles, forming a wave. Then the question is, some water in the ripple tank is removed. The water becomes less deep. No other change is made. State how the change in depth affects the wavelength and the speed of the wave. So water in ripple tank is removed. Now water becomes less deep. Depth is lesser. So that means water has become shallower. Hmm? And when waves go from deep to shallow region, what happens to the speed and wavelength?
Does the speed change?
It does. But how? The speed decreases. The speed decreases. The wavelength decreases, right? So whenever whenever water moves, water waves move from deep water to shallow water, the speed decreases, the wavelength decreases, while the frequency remains the same, right? Frequency remains the same. Frequency is unchanged. Let it be diffraction, refraction, reflection. Frequency can never ever be changed. Reason behind being that frequency is determined by what? Frequency is determined by the source, right? Okay. A student reads in a textbook that speed of sound is about 300 meters per second. He plans an experiment. Okay, so we have not done sound yet. We'll just skip this one. We'll move to the next question. All right. The question says, figure 6.1 shows scale drawing of plane wave fronts approaching a gap in a barrier. On figure 6.1, draw the pattern of the wave fronts after the wave has passed through the gap. So, can
It
you
will
people
be
look
in
at the...
semicircles.
Very good. They would be forming semicircles, right? So, how you come to know that this will result in semicircles?
Because when the wave will pass through this gap, it will spread in different
What if the
directions.
gap? What if this barrier was made like this? If this barrier was made like this, would there still be semicircles forming?
Yeah, but there wouldn't be that, it
There
wouldn't be
won't be.
semicircles. They would be
Why?
like
Why? Why?
little bended.
Because the space is more,
So that
so it
means
has
Yeah,
more
we
space
need
to go
to...
in different directions.
the
Exactly.
smaller
So
the space, the more circular it will be.
exactly. So the smaller, how much smaller? If this all this separation, this opening is about the size of the wavelength, about the size of the wavelength. See, this is the wavelength, right? This is the size of the wavelength, and the same is the size of this opening. If the size of the wavelength and opening stays the same, that means there would be what? There would be maximum diffraction. And in maximum diffraction, you will see semicircles being formed. What will you see? Semicircles being
Semicircle.
formed. And you need to make sure that when you are forming semicircles, the wavelength doesn't change. The wavelength doesn't change. So in diffraction, the wavelength doesn't change, it stays the same. The wavelength should be the same. The wavelength should be the same, right?
Yeah.
And you need to make at least three. You need to make how many wavefronts? At least three diffracted wavefronts. And can someone quickly recall the definition of diffraction?
Um, it is the spreading of wave after passing in
An opening
opening of an edge.
or an edge, right? Very good. So the wave approaching the barrier has a wavelength 2.5 and speed 20. Calculate the frequency. So frequency is what? We know that V is F lambda. So frequency is V upon lambda. What is V given? 20 centimeter per second. And what is wavelength given? 2.5. So what is the frequency? Calculators out, please.
8 hertz.
8 hertz. 8 hertz. Right? State what happens, if anything, to the frequency of the wave as it passes through the gap.
The
Well, the
frequency stays the
frequency does,
same.
yeah, it doesn't
Stays the
change.
same. Frequency is unchanged. Frequency stay same. Explain in terms of diffraction why radio may pick up low frequency radio signals but not pick up a high frequency radio signal when the car is traveling behind a hill. So basically, diffraction is more when the wavelength is more. Longer the wavelength, more will be the diffraction, isn't it? If I make, if instead of this frequency, this wavelength, I bring in another wave which has a wavelength double of this, will there be more diffraction? Yes, right?
Yeah.
So if I look at this equation, even frequency is V upon lambda, that means more the frequency, lesser would be the wavelength, and lesser the frequency, more would be the wavelength, right? So question is saying that in terms of diffraction, why car radio may pick up low frequency radio signals but not high frequency radio signal. Low frequency radio signals can be picked up because they have
Because
high
they would have more
long...
wavelength, so it would reach
Yes,
out further.
exactly. they have more wavelength and they would diffract more. They would diffract more. Okay. So low frequency waves have longer wavelength. Longer wavelength. So they diffract more and reach more. Okay. All right. Then there's this next question, which is saying a water wave in a ripple tank travels from a region where the speed of the water is faster to a region where it is slower. Figure 6.1 is one quarter scale diagram that shows the wavefronts in the region where the speed is faster. Take measurements from the scale diagram to determine the wavelength of the water as it travels in the faster region. So we need to find the wavelength. A very easy method to find the wavelength is to find the distance of all these wavefronts, and these wavefronts results in how many waves? 1, 2, 3, 4, 5, 6 waves, right? These wavelengths result in 6 waves. Now, please tell me what's this distance?
2.8.
2.8 is the total distance.
Yeah.
2.8 centimeter, right? So that means one wavelength lambda would be what? 2.8 divided by 6. 2.8 divided by 6. That will make it what?
0.46.
0.46.
I got 0.5.
Okay, fine. 0.46 centimeter.
Yeah.
Right.
Yeah.
Then the speed of the wave in the faster region is this. Calculate frequency of the wave. So faster region, this is the faster region. You know the wavelength. You know the speed. You can find frequency. So what was the equation? Equation was V equals F lambda. You need F. F would become V upon lambda. V is a 0.39 meter per second. Remember, 0.39 meter per second. And what you have calculated is in centimeter. And one more thing, they are saying determine the wavelength of the water as it travels in the faster region. You need to look at the scale as well. You need to take care of the scale. So the scale represents 1 centimeter equal to 4 centimeters, right? That means the wavelength over here even is going to be multiplied by 4, because my answer is 0.46 centimeter and 1 centimeter is 4 centimeter in actual. So what would this answer be? 1.84, I guess. Check it out, please.
Yeah, 1.84.
1.84 centimeter, right? And this same answer in meters would be further divided by 100. So it would be 0.0184 meters. 0.0184 meters, right? So I would not use 0.39 here. I would use 0.0184. All that divided by, sorry. 0.39 was the speed, not the distance. So 0.39, yes, that would be used. And the wavelength is what? 0.0184. So please, can you calculate this?
I got 21.1.
21.1.
9. So are we gonna round it off to
21.1, right?
yeah.
Okay. Okay. On figure 6.1, draw lines that indicate the position of the wavefronts of the water wave in the slower region. So slower is shallow. Slower is shallow, right? Shallow, slow is shallow. Slow is shallow, right? Slow, shallow. दोनों के end में both of these words have low at the end. So slow is shallow. All right. Now you need to draw lines that indicate the position of the wave fronts. As wave go from deep to shallow, I told you this
Away
word
from water.
away from normal, right? Deep to
Yeah.
shallow, away from normal. So I'll make a normal over here, and let's say this is the normal. And if this is the normal, let's say this was the original wave front. So original deep to shallow, away from normal, this is the normal. Meaning it would bend something like this. Is it?
Yeah.
Yeah.
All right. So can you see all these wave fronts are parallel to each other? All these wave fronts are parallel to each other, right? And they are equally spaced. And you can see that the wavelength of the refracted wave fronts is lesser than the wavelength of the incident wave fronts. Is it?
Yeah.
So that means whenever you go deep to shallow, the wavelength decreases. Was that what we discussed a while ago?
Yeah.
All right.
Yeah.
Going further, on figure 6.1, draw that's done. State what happens to the frequency of the water wave as it passes into the slower region. So frequency remains unchanged. Frequency stays the same. Frequency stays the same. All right. Any confusion? Any problem?
No.
Okay. Please read this question. Done. So figure
Yeah.
Yeah.
5.1 shows a metal strip held in the clamp. End of the strip is pulled down and released. End of this strip is pulled down to point Z. It's released and it oscillates between X and Z. It oscillates between X and Z. So X and Z are the extremes. Y is the mid position. Explain what is meant by frequency of the strip. What is
Number
frequency?
of vibrations per unit time.
Great. Number of vibrations or number of oscillations per unit time. Number of oscillations per unit time. Okay. Then amplitude of vibration of the end of the strip.
The
So
maximum distance from normal.
maximum displacement from where? I say it's not distance. It's maximum displacement. Maximum displacement. From where?
I wrote from the roof
From
position.
from rest position, or what we call the mean position, or what we call the equilibrium position. So maximum displacement from mean position. Maximum displacement from mean position. Okay. Okay, this is a sound question once again, so we will just skip this. Ultrasound, not doing that either. This is question number 4. Please read it again. All right, so what is meant by compression, beta? A region of high pressure. Compression is region of high pressure. Compression is region of high pressure. Compression is a region of high pressure. Distance from point P to point Q is 8.5. It takes 25 milliseconds. Milliseconds means what? 25 divided by 1000. Milliseconds means 25 divided by 1000. For the compression at P to reach Q. For this sound wave, determine wavelength. What do we need to determine? The wavelength, right? So wavelength is what? How many waves are forming between P and Q? 1, 2, 3, 4,
5.
5. So 8.5 divided by 5 is the wavelength lambda. That is equivalent to what? What is the answer to this?
0.7.
1.7.
1.7.
Yeah,
Are you serious?
1.7. Actually, I spoke the wrong thing.
Okay, 1.7 meter. Okay. The frequency. Frequency is what? Yes.
V upon lambda.
Okay, V upon lambda. Do I know V?
We can figure out V because it's distance upon time.
So it's just 2 marks. Wouldn't that be a longer process? Can we just
Yeah, it
use
would
F
be.
is equals to N upon T? Hmm? How many
Yeah,
waves are formed between P and Q? 5 waves are formed.
5.
What's the time?
0.00025.
0.025. Divide by 1000, no? 0.025. So
Oh,
what is that?
200.
200 hertz. Very good. 200 hertz. All right. Okay. As it strikes the wall, sound reflects. Again, sound question. We are not doing sound right now. Okay. State how longitudinal wave differs from a transverse wave. How is longitudinal wave different from a transverse wave?
Transverse waves go up and down, while longitudinal waves go from like moves from like one point to other.
Perfect. Perfect. So basically, you can just rephrase this like longitudinal wave have compressions and reflections, right? And transverse waves, they have troughs and crests. Or you can say that in longitudinal waves, the wave vibrate at right angle to the direction of wave. Or you can say the particles vibrate at right angle to the direction of wave in a transverse, right? Or you can say that the medium vibrate or oscillate at right angle to the direction of wave. While in a longitudinal wave, the medium vibrate parallel to the direction of wave. The wave particles vibrate parallel to the direction of wave, right? So I'll just write longitudinal wave. Longitudinal wave consists of compressions and rarefaction. Wave has compressions, and rarefactions. Transverse wave have transverse waves have refractions, have crests and troughs. All right. Sound wave of frequency 7.5 kilohertz. 7.5 kilo means 7.5 multiplied by 1000. 7.5 multiplied by 1000, that will make it how much? 7500 hertz, right? Through a steel beam of speed 6100 meters per second. Calculate wavelength. So wavelength is V upon speed. F is the frequency. V is 6100 meters per second, and speed is 7500 hertz. Is it?
Yeah.
So that makes it how much?
I got 0.81.
0.81 meters. Is it right?
Yeah.
I'm asking the other student.
Yes, sir.
0.81 meters. The sound wave passes from the end of the beam into air. Sound wave passes from the end of the beam into air. State the effect on the speed of the sound. State the effect on the speed of the sound. So it passes from beam to air. What is beam made of? Steel, right?
Yeah.
So what happens to the speed? From beam it goes into the air. Is the speed more in air or more in solids? Speed of sound. Yes? Technically, this is part of the sound again, but speed of sound is more in solids. You need to remember that, right? So if it goes from the beam, that's the solid, to the air, that's the gas, then the speed would decrease. The speed would decrease, right? So solids have the greatest speed of sound, then liquids have a little lower than that, and then air has the least speed of sound. Okay? Effect of wavelength. Definitely, if speed has decreased, so will the
The
wavelength
wavelength will
decrease.
also decrease.
Wavelength decrease, right? Wavelength decrease. Okay. Any problem? Any confusion? All right. And then there's another question. Two types of seismic waves are produced by earthquake. They are called P wave and S wave. P waves are longitudinal waves. S waves are transverse wave. what is meant by the term longitudinal and transverse? So in longitudinal, vibration of the wave or vibration of particles of wave is parallel to the direction of wave travel or wave propagation, right? So in longitudinal, what happens? Vibration of particle vibration of particles is parallel to direction of wave, direction of wave direction of wave, while in transverse, vibration of particles vibration of particles vibration of particles is perpendicular. Vibration of particles is perpendicular perpendicular to the direction of wave, perpendicular to direction of wave, right? Any problem, any confusion, beta?
I have a question.
Yes, please.
So the previous question we did, you were talking about sound or something being like in solid. It's like I didn't
More
understand what
speed.
you really got. I didn't get it.
Okay, sound is the topic we have not done, but there was this question that popped in, and we have read it. So I was just solving that. See, when I talk about the speed of sound, na, sound travels faster in solids, the fastest. Then they travel in liquid, and then the least speed of sound is in air. If I talk about speed of sound in air, it's around 330. It's around 330, right? In liquids, it's 5 times more. It's 5 times more, right? In liquids, it's 5 times more. So that's around 1500, right? And in solids, it's 15 times more. It's 15 times more. That means it's something around 5000. Okay, if you want to experiment this, tell me, wherever you are seated right now, do you hear any sound other than my sound?
Um, no, because I have headphones on and I can only hear
Yes
you.
or no?
Yeah, I can hear
Okay.
other sounds.
Okay, just okay, what other sound can you hear?
My brother using the controller.
Okay. Other than that, nothing?
I
No.
can I can hear my surroundings. I can hear like the door closed and
All
like
right. All
the
right.
other
All
stuff
right.
that's
And is
happening
the
around.
fan or air conditioner in your room working right now?
No, it's off.
Yeah, it's turned
It's
off
off.
because it's
Okay.
cold.
Okay, all right. Just put your head down on the table such that your ear is touching the surface of the table. And then let me know if you hear something.
I hear like a hollow voice
Yeah,
and
like
like
some
noise.
vibrations, those weird
Yeah.
noise.
Some vibrations. You must be hearing some vibrations, right?
Yeah.
That's and that same vibrations you are not hearing while you are in the your ears are in the air, right? Is it?
Yeah.
So
Yeah.
sound travels faster in solids than gases or liquids. Okay? You must have, if you watch classical movies, you must have seen that when in old times, uh, when people were to detect if there's some army approaching to attack or not, they used to put their heads down, their ears down on the ground to detect if some army is approaching or not. Do you
Yeah.
know this fact?
Yes.
So why? Because
Yeah.
ground is solid, vibrations transfer more faster. Why? Because molecules are close together. So if one molecule vibrates, the other does too. Right? But in air, the molecules are further apart, particles are further apart. If even one is vibrating or has high energy, it will only transfer its energy if it collides with the next molecule. And it rarely happens because the distance is much larger, isn't it?
Yeah.
So that's the reason. Now state another example of longitudinal wave. They have already mentioned one example, longitudinal wave. Another example is sound wave, right?
Yeah.
Sound wave. And transverses, you can mention anything. There are a lot of them.
Yeah.
Light
Water.
wave. Yeah. Seismic wave has a speed of 7.2 kilometers per second and frequency 30 hertz. Calculate wavelength. So wavelength is V upon F. All right, and V is what? 7.2 kilo. Now it's kilometers. We need to multiply that by 10 power 3 or 1000 to make it meter per second, right? 7.2 kilometers per second means 7.2 into 1000 meters per second. Okay, is it?
Yes.
All right, and divided by 30. So please give me your answer.
Is it 240?
Please confirm.
Yeah, it's
240.
All right, 2 into 100. Yes, it's 240. 240 unit meters, right? 240 meters. So got it? Understood? Any problem? Any
no.
confusion? Okay. So we'll keep it till here and continue from the same point in the next class, inshallah ta'ala. All right?
Okay.
Okay.
Sir,
Okay. Assalam.
you didn't add us on Google Classroom.
Okay. Please confirm if you are added now. Just go check your Gmail.
I'm
Okay.
added.
What about?
I am just checking. No, there's no class here on my side.
I've sent you an invitation. Check your Gmail.
Okay, I will. Yeah, I got the invitation right now.
Got it? All right. So we keep it in here, continue from the same point in the next class. Until then, take care. Assalamu alaikum.
Allah Hafiz.
Lafis.
Allah Hafiz.